start directly.
You can start now.
Yeah, sure. Okay, hello everyone, guys. Am I audible to you? Could you give me the quick confirmation? Are you there? Thanks, Sid, for the quick confirmation. Okay, great. So let me quickly share my screen. Okay, is my screen visible to you? So as per the today's agenda, let me quickly tell you what we are going to discuss in our today's session. Okay, so as per the today's agenda, we are going to discuss about some data structures, like we are going to discuss about the simple data structures. Like let me make a note here. Okay, so the data structures which we are going to discuss: stack, queue. We will try to implement one data structure with the help of array DSA, like array data structure. One we will try to implement with the help of linked list, so we can understand how it is getting implemented as well. We will understand the algorithm, we will discuss the concepts, and after that we are going to discuss how to be implemented. Later on, we are going to discuss about the trees data structure, how it is going to work, and after that we will try to implement that tree data structure as well. And the major thing which we are going to discuss about one application, like we will implement one to do app kind of application with one data structure. Over there also we can take any one of this, like we will try to use array or linked list, and using that we will implement a proper functionalities, and we will understand how it is getting executed and how we are going to use this data structure. So this is our today's fundamental. So we will try to divide that, like as we have some 2 hours of time. So we will take half an hour for stack, half an hour of queue, or let's say 20 minutes we will take for each, and last 20 minutes I will keep for the doubt clearing class, like doubt clearing things we will do. So whatever the questions, whatever the doubts that you have, we can discuss on the same. Okay, good to go. So these are the things which we are going to discuss. You can send me the message on the chat, guys, so we can quickly discuss. Like I can see your messages. Okay, so that's it. I hope you are able to write the message. Yes, great. I can see the messages. Thanks for your quick update. Okay, so the first thing which we are going to discuss is a very powerful data structure, because this data structure is having so many real-time implementation. So we are going to discuss the same. So let's understand stack. So stack is the data structure, which is something, if I will give you a real-time example here, let's say a stack of coin. Let's say the stack of books. When you are keeping the book, like, okay, book 1, book 2, book 3, book 4, like some stack if you have created. Now let's say from this is the book 1, book 2, book 3, book 4, book 5, book 6. I kept it like that. Okay, when I am keeping them, I am executing like this. Okay, push. Then I have executed one more push. Then I have executed one more push. Here, let's say push. This is also push. This is also push. So I'm able to push the data in a stack. It's a kind of container. Let's push 1, then 2, then 3, then 4, then 5. Like that. Now, when you remove the elements from the same, you are saying, okay, pop. So it will become like this. 1, 2, 3, and 4. Okay. When you do again pop, it will become like this. 1, 2, 3. When you do pop again, it will become like this. 1, 2, 3. Sorry, 1 and 2. pop it again, 1, pop it again, your stack becomes empty. Okay, so this is something which we can implement it. Push and pop. Push is something is going to push the element on the last place. Pop is something which is going to remove the element from the last place. So here everything is happened from the one side. We have only one side, and on the one side we are going to execute this. So always stack data structure, always use the top location. And from this top location, we are going to use this stack. So this is something we can say that the powerful thing which we are using while working with the stack, because we have only one side. एक ही जगह है जहां से आप डेटा इंसर्ट कर सकते हो और उधर से ही रिमूवल होगा. यू डोंट हैव एनी अदर प्लेस. मतलब इंसर्शन के लिए और रिमूवर के लिए वी हैव ओनली वन साइड, दैट इज कॉल्ड अ टॉप. ओके, सो you will use top for the data insertion, you will use top for the data removal. So this is something which we are implementing while working with this stack. Okay, let's say our stack is having a fixed size like a 5. You can store only 5 element inside your stack. If you have already inserted the 5 elements in your stack, after that when you try to insert a new element, what happen? It will say stack overflow. Okay, if you have removed all the elements, pop, 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 and when it reaches to the last element, when your stack become empty, if your stack become empty, then what message you will get? Stack underflow. So stack overflow and stack of underflow is something like when the stack is full, you will get the message your stack is overflow. Now you can't store some more elements inside the same. And if you are trying to pop the elements, but if you reached at the last location, so after that you can't remove anything, right? So that is something which you are going to get. That is that error message. You can see that, okay, it's a stack underflow. Now there is nothing to pop from your stack. It is something like, आपको एक real time example दूं. Are you aware with the browser history? So browser history में अगर आप कुछ search करते हो, first value, next value, next value, next value, तो जब आप back आते हो, so when you do back, it will show you the previous one. Let's say previous data, previous data, previous data, जितनी बार आप back करोगे. Now last में ये button disable हो जाता है, because जो लास्ट पॉप था वो खत्म हो गया. नाउ देर इज नथिंग इन योर स्टैक. हिस्ट्री में अगर कुछ है ही नहीं तो व्हाट इट इज गोइंग टू शो यू. So at that time this button become not clickable. You can't click on that. So that is something which we can manage with the help of this stack. Okay, yeah, sure, Balaji. I was just talking about browser history is actually implemented with the stack data structure. Okay, so if you are going in the, like if you want to access the history in the back side, when you click on the back button, so it will try to do the pop, and that previous access the or visited website, you can see it from your browser. So this is how you can understand the stack implementation. Okay, so what we will do, we will try to implement stack using array data structure, and we will try to implement queue using linked list. So let me quickly show you how we can implement that stack data structure. Okay, shall we try? Are you clear with the basic implementation, like the logic? What happened with the pop function? What happened with the push function? What is the meaning of empty stack? What is stack overflow? What is stack underflow? Are you clear with the same? You can quickly respond me. Great. Okay, so what we will do is, let's quickly try to open our Eclipse IDE. Yeah, so I'll open that same workspace where I have opened the, like created the projects yesterday. Over there only I'm going to create today's project. Yes, okay. So what we will do, we are going to create one class. In that we are going to declare one array. Okay, we will create one constructor. In the constructor, we will define the size of the array. Okay, what we can do is here, let's say there are so many files are open. If you want to close all your files, you can just close all this in your Eclipse. So your things will get clear. Okay, now I'm trying to create one more Java project. Okay, so let's say here I'm just creating the project name with the DSA. Okay, let's click on next and then finish. Okay, so my project is ready. Now here I'm just trying to create one package. Let's say package. So package name I am giving, let's say org dot let's upgrade dot stack. Like I want to implement the stack here. So that's why I have given the package name as in stack. Okay, now inside this I want to create one class. Class का नाम देंगे stack. Okay, so this is going to become my main class where I'm going to write the logic of my stack implementation, like push function, pop function, all the logics I will write here. Now the first thing, variables. We have to give the variables here. Okay, so let's declare some variables. Always try to declare the variables using private keyword. So it is not going to access outside of this class. Okay, I'm creating an array. Okay, and let's say this is going to become my stack array. Okay, after this, I'm going to write one more variable because I want to understand the top. Like top is the one place from where you are going to access your entire stack. So I'm just giving the top value. Let's say top. Okay, one more variable I am creating. It's the capacity of my stack. While creating the object, we will give the capacity like, okay, in your stack, you can store 10 elements or 50 elements or 1000 elements. Okay, so this we are going to define in a constructor. Okay, so what I will do is let's write a constructor. So if you want to generate a constructor, you can simply say public, the class name, and this is going to become one parameterized constructor. And here I am going to take the size. Okay, so I will take the size. Okay, and this size I am going to assign to this capacity. So what I will do is the capacity of my stack is similar to the size which is given by the user. Okay, and based on that size, I'm going to create the object of this stack array. So let's say the stack array. I will create a new int array and with that size which is given by the user. Correct? Okay, and by default our stack is empty. By default, our stack is empty, means there is no elements are there. So what will be the top value? See, it's a array. So array starts from 0 index. So if your array is empty, means you are at which index? -1. Okay, because array starts from 0 index. So what I'm doing is, I'm saying, okay, -1. Correct? So okay, whoever is having a doubt, please don't raise your hand right now. I will take your doubts after completing a particular topic. So please pause right now. Let me finish this. And after that, I will take your doubt. Okay. So after this, once this is done, now we will start writing the functions. Like, okay, from here, I'm going to write the logic. Let's say public void push. I want to push one element. So for pushing the element, obviously, I will take one element from the user. Okay, or you can give it manually as well, like, okay, what is the element that you want to give? Okay, this is something. Yeah, okay, I'm just aligning the content. Yeah, so now this element I want to push. So where you want to push, obviously we have to check first of all, is our stack is empty or not? If it is not empty, then how you will push the value? So we have to provide the message, okay, our stack is overflow. So for that, I'm going to create one more function. Like I want to check whether my stack is full or not. Okay, so for that, let's write a function. Public. Okay, I want to check it. So that's why I'm giving the return type, let's say Boolean. Okay, I will say is full. Is my stack is full? Okay, I am checking. So how you will check it? I will say return if the top value is equals to capacity minus 1. Okay, if the top value is equals to capacity minus 1, then it will return true. Otherwise, it will return false. Similar to this, I can also write a function for checking is the stack is empty. So I can also write is the stack is empty. So here I can check if the top value is equals to minus 1, then the stack is empty. Simple. If this is going to return true, means the stack is empty. Otherwise, the stack is not empty. Okay, clear with this logic, everyone? Now here I want to check is my stack is full. If it is full, we will provide the error message. Otherwise, we do the insertion. Okay, so I will check if is full. Okay, so if it is full, then we will provide the error message. Okay, stack overflow, and we will return it from here itself. Like, don't try to execute the below lines of code. Stop execution from here. Okay, in case if it is not full, then what we will do, let's say in my stack I will try to put the element with the top value. Okay, so top is minus minus, so I will do plus plus, means it I will put the first element at the 0 index. When it goes to the 0 index, that given element, like which is entered by the user, so we will push, and after that we will print the message like, okay, element pushed successfully, element pushed. Okay, and you can also put the element like, okay, this is pushed. Okay, so till this, everything is clear. I hope you guys are clear with this. Similar to this, let's write a logic for, I'm just copying this entire logic and we will make some few changes. Let's make pop. Pop means you want to pop the element. So make it without any parameter. When you do pop, obviously it is going to return a value which is popped. Okay, is the stack is empty. Okay, is the stack is empty. In the pop case, we will check is empty, then we will provide the error message stack is under flow, and we are going to return the value which is minus. Okay, in case if it is not empty, so what we will do, we will provide the message first of all, element popped. Which element is popped? So that we are going to say from the stack, array, I want to remove the very first element, that is the top element. So I am just printing right now, it is popped. Okay, let's return that. So how you will return that? From the stack. Okay, I will try to do top minus minus. Means what it will do, let's say you are removing the element from the 0 index. So it will return the element from the 0 index and the index will become minus 1. So this is something which we are going to execute here. Is that clear till this part? Logic? Everyone? Great. Okay. Now what I am doing is, in case if you want to check which element is available on the top, you don't want to remove, you don't want to push, you just wanted to check which element is available on the top. So for that case also, we can write the similar kind of logic. That method name is, let's say, pick. Pick. Okay, so pick will check is the stack is empty. If it is return empty, then return minus 1. In case if it is not empty, we will just return the value which is available on the top. We will just return the value which is available on the top. Just return the value which is available on the top. We don't want to do anything with this. We just wanted to check, okay, what element is available on the top with the pick. Push means insertion, pop means removal, pick means just to check which element is available on the top. That's it. Is that clear till this part? Great. Okay, so now we want to start this execution. How we are going to use this? Okay, so for that, let's create a main method. Okay, so for that, I'm creating a new class called main. Okay, in that, I'm creating a main method. Let's create the object of a stack, which we have just created, stack, my stack. Let's try to make a coin stack, like coin stack. Okay, new stack object. And we'll say, I just wanted to create a stack of 5 coins. Okay, so coin stack dot push. Let's say I want to push coin 5. Okay, similar to this, I'm just trying to repeat the value. 5 coin, 10 coin I want to push, number 2 coin I want to push, 1 coin I want to push, and 20 numbers coin I want to push. So I'm trying to push this. Let's try to push one more value. Let's say I want to push one more coin, that is 10 again. Okay, and let's run this. Can you see? 5 is inserted, 10 is inserted, 2 is inserted, 1 is inserted, 20 is inserted. But when we are trying to push 10, it is giving me the error message, stack is overflow. You can't push now more elements. Okay, now I want to see which element is available on the top. Okay, so this line will gives what? Stack overflow. Okay, after that, if I will do coin stack, I just wanted to print coin stack dot pick. Which element is available on the top? Is on the top. Okay, so now if you run this, see 20 is on the top. Now let's do the pop. Similar to this. Okay, from here only I'll say coin stack dot pop and I want to pop. Let's try to pop 3 times. And after that, we will try to access the peak value. Okay, let's see that. Can you see 20 popped, 1 popped, 2 popped? So when 3 elements popped, now I'm getting 10 is on the top. So 10 is available on the top. Okay, again if I will do 3 times pop, what happened? So see, 10 is popped, 5 is popped. After that, the top become -1. So when it is become -1, can you see it is giving me stack is under flow. So this is how, guys, we can implement the entire data structure using stack. Okay, good to go, guys. Are you clear with this concept of stack? We have implemented one class. Our class is having, if I will try to explain this in a proper way, I can just tell you like this. This is something which we have implemented. Like we have implemented the stack with the 3 values. One is the array. Okay, one its size and one is the top value. Okay, based on this, like these are the 3 member variables. Okay, when for the very first time when we are saying push 10, what happens? It is trying to push the value in this array, 10. What is the size of our array? We have 0, 1, 2, 3, 4. Because I have mentioned the size is 5. Second time when I am doing push, it is saying 10, 20. Third time when I say push 1, 2, and 5. This is something pushed. Okay, so all the push executed. When I am trying to push one more time, here you can see there is no space. Means this is giving me the error stack overflow. Right now, if I say peak, can you tell me what I will get with the peak? What value I will get with the peak function? Great, I will get 5. Okay, if I will do pop, what I will get? For pop also, which value I will get? Very good. Now again, if I will do peak, what I will get? Very good. Okay, so this is something how the stack is getting executed. I hope guys you are clear with this stack concept. Good to go? Okay, by checking this structure, can you tell me where we should use a stack data structure? Any example which you are aware? GTG, what is GTG? Are you aware with the undo redo functionality? Good to go. Okay. Okay. Are you aware with the undo and redo functionality? Now, right now, I have done so many things on this notepad and I have removed all the things. Okay, now if I want to do the undo, you must have aware like there are some 50 times you can do the undo. Okay, on this paint only. So if I do Control Z, can you see? This is coming from the stack. Pop, 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 pop. Can you see? This is executing pop. Until the stack will become underflow, the pop will execute. See, pop. After some level, the pop will stop executing because it becomes -1. See, can you see now it stops? Now the pop is not working because the undo, like the stack is having a limited capacity. Let's say 50 time pop done. After that, it is not doing any kind of execution. So undo and redo functionality also you can implement with the help of the pop. All the editors, Paint, Notepad, any kind of editors which you are using, happily they are using the stack data structure. Okay, then JavaScript is also using the stack data structure for executing the call stack when the functions are getting triggered. When you are doing reversing a string, over there also we are using the stack data structure. Other than that, expression evaluation. Let's say you must have executed the expression like 5 plus 3 plus 2 minus 4 divide by something. So here also stack used, like implementation programmatically if you want to execute, not manually. Manually you are going to write your own logic. For programmatically expression if you want to execute, over there also you have to use the stack data structure. So these are like so many examples, like puzzles if you want to use in the games, puzzles, mazes, over there also we are using the stack data structure. Okay, other thing like balancing, right now also if I will not write one curly bracket here, I will get the error. So this is maintained with the help of the stack. Okay, it is just tracking the curly bracket to curly bracket, round bracket to round bracket. So that balancing, bracket balancing also you can do with the help of the stack data structure. Okay, so these are some common examples which we are using with the help of the stack data structure. Good to go? Clear with the concept? Yes, okay. Thanks for the quick confirmation. Now, I'll just take a pause here for 1 or 2 minutes. Let me know whatever the doubts that you have. Quickly, whoever is having a doubt, You can try to write a message in the chat. We will quickly check that. Please do it fast. Otherwise, we can proceed. No doubts? Okay. So I think there is no doubt now. Let's quickly proceed. Okay, no doubts till now I got. Yeah, thanks for your confirmation, everyone. Um, Next data structure is a very powerful data structure, that is queue. You must have seen the queue, right? When you purchase the movie ticket. Okay, when you go for the vote. So obviously you have to stand in the queue, and after that only you can do your process. Now stack is something which is trying to execute on the top. Simply we can say that last in, first out. Queue is something which is saying we are like this. Insertion happens from one side, removal happens from the another side. So I can say that this is the front page, and this is, we can say that, back, or we can say that rear side, front view and rear view. So insertion happens from the rear, removal happen from the front. So let's say 10 inserted, 20 inserted, 30 inserted. So the one which is inserted first, it is going to exit first, like first in, first out. This is something which has happened with the queue data structure. So obviously, if you have a two and then only one side can enter and other side can do the exit, right? Entry and exits are the two different places. At that time, we can implement the queue data structure. Okay. So can you give me some real-time example, like where usually we are using queue? Any idea? Like movie ticket queue, waiting line, call center, customer support. Some programmatic example. Do you know printer? Printer, you must aware with the printer, right? So printer, how printer is printing the document? Printing documents always happens in a queue. Page 1, page 2, page 3, page 4, like the printing process is executed. In case, yeah, printing and scanning document, very good. So in case if you are working in an office, let's say this is the one printer. And obviously this printer is, let's say one printer is connected with Sonam, one printer is connected with LX system, one printer is connected with some, let's say David's printer, and one printer is connected with, let's say John system. Now all have done the print command together. Now the queue triggers. Okay, let's say Sonam triggered first. So Sonam is first in the queue. Let's say this is second, this is third, and this is fourth. And based on that, the execution happens. First, Sonam's documents will get printed, then David's, then John's, and then Alex. So this process is always executes in a queue. Okay, when you are trying to execute some order, then also that order placing process, CPU task, computer task scheduling always executes in a queue. Okay, number of tasks you are trying to execute. Okay, one more thing, downloading the document and uploading the documents. This process is also executed in the queue. Okay, so these are some real-time examples where we are actually implementing the queue. Okay, is that clear? Are you clear with the real-time examples of queue? So now my requirement is I want to implement queue using linked list. So we are going to create, let's say, one class, which is the node class. We are also going to create the another class, that is the queue class. Okay. Node class will have only one constructor, whereas in the queue class, we are going to implement the different types of methods, like and insert the elements. Means for that we will write enqueue logic. For removing the element, we will write the logic using DQ. Okay, so NQ, DQ. Here also we can write the logic for the peak element. So these are some functionalities which we are going to implement in the Q data structure. Okay, so let's start writing the logic. Okay, what is your, if I ask any question first, then you are going to give the answer using Q. Okay, you are trying to give the example of the Q. Got it, got it, got it. Yeah, that is true. Like when the raise hand happens in this Zoom meeting, let's say there are 10 people who did the raise hand. So when I get the notification also comes in the queue. Okay, who raised the hand? This student raised the hand, this student raised the hand. Also, on your LinkedIn, on your Instagram, how you are getting the notification. So that is also coming in that way, right? So let's try to implement this with the help of linked list. Okay. So now we are going to not use array, but we are going to use linked list for implementing the queue data structure. So for implementing the queue, the step number one, I'm going to create a package. Obviously, my package name is going to become queue. Hello everyone. Guys, am I audible? Yeah, so sorry, I was disconnected. I don't know what happened, and suddenly I was thrown out from the Zoom meeting. So I was just waiting for the presenter access. Okay. Um, yeah, I think now all good. Everybody, can you see my screen also? Yes. Great. Thanks for the quick update. Great. Okay. So the thing I was creating a package named Q. Okay. And under this Q package, obviously, I have to create one class. I'm going to create, let's say, one class named node. Okay. I'm going to create one another class that is Q class. And I'm going to create one more class that is the main class. Okay, so one is the node class, one is the Q class, and one is the main class, right? So how we have created the node yesterday, similar to that, we are going to create the node for here as well. Okay, so what I'll do is inside this, I'm going to write, let's say, data. Okay, and the another node that is the next node. Obviously, we have to use node as an constructor. Okay, we will take the data. And what we will write a simple logic here. I will assign this dot data is equal to data. And I will say next is equal to null. This is the simple logic which we did yesterday as well, right? Because I want to show you the example of both the data structures. So stack I have shown you using array, and this because in our module, like in our module explanation, it is mentioned either use array or use linked list for implementation. So let me show you here in this description also. So I'm just trying, I cannot show you both the things together. So for stack, I have shown you array, and for Q, I'm trying to show you with the linked list. So I'm just trying to cover up both the kind of perspective. Yeah. So that's why. Yes, linked list support the dynamic memory allocation, which we have discussed yesterday. Whereas array is sequence, it requires a sequence. So sometimes internal fragmentation, external fragment kind of problem happen with the linked list. Okay. So what I'll do is here node is ready. Now I'll go to the Q class. Okay, now under the Q class, what I want to do is, let's create private. I'm creating node. Okay, for the two types of node I want to create. One is the front side and one is the rear side. Okay, because here we have two end. Okay, normal linked list is having only one head, but here we have two end. One is the front end and one is the rear end. So I have created two. One is front and one is rear. Now the next thing which I want to give is, let's say, let's give the size also. Okay, so I'm trying to give the size as well. Okay, after that, let's create a constructor. So in the constructor, let's say I want to define front, rear, both the nodes. By default, I'm giving null at the time of initialization. At the time of initialization, make the nodes null. Okay, now let's give the by default size. Obviously, there is no element in my queue. There are no persons standing in the queue. So let's make it 0. Clear with the same? Now, the next thing which I wanted to do is after this. Okay, I want to write one function. Let's say Boolean. I want to check is my queue is empty. Okay, so for checking the empty, we can just check the size. Okay, so simply size also you can check, or also you can try to check it like this. Return if the front node If the front node is equal to null, simply we can say that the queue is empty. Simple. If size is 0, then that also you can check. And if you are saying if the front node is null, then also you can say that your list is empty, like queue is empty. Okay, now let's try to insert a new element. So for insertion, I will say enqueue. Okay, so for the enqueue, obviously we will ask the user to give some information. So user will give us some data. Okay, so when user will give us the data, we will create a new node. Okay, just like how we did yesterday. Okay, using new node, let's create a node, pass the data. Okay, now my first thing is, see, okay, what we need to do is, in your, let's say this is our queue. This is front, this is rear. I am trying to give the first element, let's say 10. And I obviously it will go here. So when it will go here, first of all, we have to check. Do we have any element at the rear place? Do we have any element at the front place? So rear we will check. If the rear is null, means automatically you can understand, okay, your list doesn't have any data. So if the rear is null, what we will do is front node and rear node, both we will assign to the new node. Because if you have only one element, this is only considered as a rear, this is also considered as a front. Okay, so what I will write here, I will just write a logic. If the rear is equal to null, then make simple front is equal to rear is equal to the new node which you have just created. So new node is assigned to everywhere, like front, rear, both the places. In case if you have the data, so after rear we have to push the new node. Okay, so if already have the data, we will just say rear dot next, and we will align the new node there. Okay, so rear dot next means after rear we are aligning a new node. Now I'll just give you one idea. Okay, I'll just give you one idea so you can understand it. Let's say, okay, let's say you have only one element. This is front and this is only rear. Now after this I am entering a new. So after rear I have entered new. So now rear got updated. Now this place is not rear. This place is rear. So this is something also we have to mention here. Means what I will write, rear is equal to new node. So pointer also I am giving and I am shifting the rear place. Like earlier the rear place is 10. Now the rear place is after the 1. Okay, so this is something which we can manage. And after this process is getting completed, I will increase the size by 1. And I will print a simple message, node inserted successfully. Or I can simply say enqueued. Okay, and what you have enqueued? So that element also you can print like, okay, this data we have enqueued. Okay, so are you clear with the enqueue process? Yeah, it's just a front and rear are the pointers. Front and rear are the pointers. So what I did is earlier, when you have only one element, like I am only standing in the queue. So what I am saying, I am the first and I am the last. But if someone coming behind me, then who is going to become a last? I am the first, but the one who is standing after me, he is going to become a rear. Okay, so I'm just shifting the pointer to the last element, right? So that is something which I have mentioned here. Okay, now let's do the similar kind of process for doing the dequeue. So what I will do is, obviously, when you do dequeue, the element is removed. So return type will not become void, it will become int. Okay, and the method name will become, let's say, dequeue. Okay, I want to dequeue. Means I want to remove the element from the front. Simple. I want to remove the element from the front. So when you want to remove the element from the front, the first thing we have to check is is your queue is empty. Okay, if it is empty, then simply you can say that there is no element are there in the queue. So nothing is there to remove. Or simply we can say that queue is under flow. Okay, and we will return minus. Okay, in case. Okay, in case if we are removing. So for that, what we will say, let's take the data which you want to remove. So I want to remove this front dot data. Okay, let's shift the position. I am front. Now I am removing myself. So the one who is coming after me, he is going to become a front. So I am changing the pointer now. Front is front dot next. So front pointer got updated. Okay. So once the front pointer got updated, means I removed, right? And after that, I will just write a logic here. Like front is updated. Now, if the front is equal to null. Why this is needed? If the front is null, like after me, there is nobody. If the front is null, then rear also become null, right? Means the queue become empty. Okay, in case the element is removed. So if the element is removed, let's decrease the size. And after decreasing the size, I will provide the message. Okay, how you will provide the message? Element dequeued. What is actually dequeued? The data which you have stored in the data variable. So that is dequeued. And after that, what we will do? We will return the data as well. Like, okay, this data is actually removed from the queue. So this is the simple logic for the dequeue process. Okay, good to go, guys. In case if you want to pick up pick execution, if you want to do so, pick is just simple. We wanted to get what element is available on the first. So pick is just a simple logic like public int pick. We will first of all check, is there any element? So we will take this. So in this case, we will return -1. Otherwise, we will return the data. So what we will return? Front dot data. Like, okay, this is the data which is available on the top, like the first element. Okay, if you want to get the size of your queue, like, okay, how much your queue is longer. So simply you can make it like int get size, and we have already declared a size variable. So let's return the size. Simple. So I have returned how many functions? 5 functions I have returned. I am getting the size, pick, enqueue, dequeue, and to check whether the queue is empty or not. So these are the 5 functions logic I have entered. Okay. Uh, Let me write here. It's empty. Pick to get the first element. Enqueue to enqueue the element. Dequeue to dequeue the element. And get size to get the size of your queue. So these are the 5 functions that we have implemented. So now if I want to write the logic, how to use it. So let's make the use. Okay, so for using this, go to the main method. Okay, and let's say queue object. Queue, I'm just trying to create my queue. New queue. Okay, so queue is created. Now let's insert some elements in the queue. My queue dot enqueue. Let's say I want to enqueue 4. Similar to this, I want to enqueue. Okay, let's say I'm enqueuing 4, I'm enqueuing 3, let's say 90, let's say 42, let's say 76. Okay, after that, if I want to print the size of my queue, size of my queue. So how you will get that? My Q dot get size. Okay. Okay. If you want to check, is the Q empty? So how you will check that? Just call the function my Q dot is empty. So it will give me true or false. Okay. If you want to get the very first element, I can just say pick. So my Q dot pick. Okay, let's say if I want to DQ, I will say my Q dot DQ. I'll just try to execute this DQ for, okay, and let's run this. So can you see 4, 3, 90, 42 and 76 are coming into the queue. So 4 first, then 3, then 90, then 42, then 76. What is the size? 5 elements are there. So the size of my queue is 5. My queue is not empty, so that's why I'm getting false. Now see, this is first in, first out. So who is inserted first? 4. So 4 is coming on the pick value. So 4 removed, then again DQ 3 removed, then again DQ 90 removed, then again DQ 42 removed. If you are trying to do it again, you will get 76 removed. And again, if you do DQ, you will get -1 because there is no elements are there after the 76. So this is how you can use Q. Is that clear? So I have implemented the Q data structure with the help of linked list. Okay. In the normal linked list, we have just used only head. But here I have used 2 node, front and rear. So whenever you want to implement any data structure, if you want to implement the stack data structure, you need only one, that is top. Okay, using linked list. If you want to implement using linked list. Okay, so you just have to create one node, that is the top node. And everything you will do with the help of the top node. Push, pop, everything. So either you implement push with array, either you implement with linked list. You need to keep it in your mind. Okay, if you want to just store and retrieve, sometimes stack is going to give you the faster performance if you just wanted to do the insertion and removal. Sometimes more implementations, if you want to do more kind of queue kind of process, if it is coming into the picture, over there you should use queue. Okay. So stack kind of things, if you think in your mind, so that is going to give you the faster performance. Over there, you should use stack. In that case, also, if you are doing only insertion and retrieval, you should go with array implementation. If you want to do some internal implementation process, like something in between, if you want to do manipulations, if you want to do, so for that, you can go for the linked list kind of implementation. So it's up to you. See, each and every data structure is having its own capability. So according to that, you have to choose, and based on that, you can try to implement the same. Is that clear? Clear with this Q data structure? Okay, I'm taking 1 minute pause here and let me know if you have any question. Yes, node is just a plain class which is having 2 variable and 1 constructor. Rakesh. DQ. Okay, so if you see the DQ code, DQ is something like this. Let me tell you. Let's say normal DQ process, I'll try to explain. Okay, according to this code. Let's say you have front, rear, 3 elements. 3 elements are there. Means who is on the front? 10. Who is on the rear? 30. When you do the DQ for the very first time, what happened? Just see the code. Is your queue is empty? No. Means let's get the data which you want to remove. So data, what you will get in the data variable? Data you will get 10. Okay, now front is getting changed. Front is changed because I want to remove this front. So this I want to remove. So who become front now? 20. So front is 20. This is something written here. Now, right now the front is not null. If the front is not null, this code will not execute. Okay, what is the size? Size is actually 3. When you do size minus minus, the size become 2. Okay, and it will print 10 is removed. Okay, now front is 20 and rear is 30. Again the process happen. See, is empty? No. Now who is going to become a front? 30 is front and 30 is rear. 30 is front, 30 is rear. Data is what? Data is 20, which is going to be removed. The size become 1. Same thing happened third time. Front is 30, rear is 30. Now what happened? Front and rear. Now when you try to change the front, now after rear, is there anything? No. So how you will get the next? This line will not execute. Front is equal to front next. Front is equal to front next. Nothing is there after the front next. Means what is the front next? Front next is null. So front become null. Now if the front become null, rear also you have to make null. So front and rear both becomes null. Size becomes 0. So this is something which is written here. So in that case, it will understand now the queue is totally empty. Rear is not pointing anywhere. Front is also not pointing anywhere. Yes. In the queue, we need 2 pointers. One is for insertion, one is for removal. Sometimes if you are using doubly linked list, we need 2 locations. Like because on the one end, you can do the insertion, deletion, both the sides. Insertion, deletion, both sides. Sometimes the queues are there. Yeah, so that is also we can implement. Real time example, if I will give you the VIP queues in some public places. If you want to visit some temple or something where the VIP queues are there. So at that time, front and rear will get updated anytime, right? A very real time example. Okay. Shall we proceed? Queue is also somewhere we can use like, data transfer, network, through network when you are sending the messages. At a time, let's say I have sent 10 messages, but that messages are received from the other side in a queue itself, packets. The data sent, the information transferred in the form of packets. First message which I have transferred, which will received over there on the first. So data transfer package is also using queue data structure. Yeah. Now let's proceed the another important data structure, tree. So tree is something we can say that the data structure which is showing the hierarchical data structure, and it is implementing the structure like a tree kind of structure. So when you are trying to implement the tree, we have something like this. Let's say this is the root node. One is the, we can say that the left hand side node. One is, we can say that the right hand side node. Here also again left, right. So if both the nodes like this, I can say that root node. These are the nodes which I can say that parent node. And these are the nodes which I can say that child node. These nodes also called as a leaf node. because these nodes don't have any kind of children. So we can also say it's as a leaf node. This is something which we are connecting through, that is actually called edge. This is the edge. And let's say level 1, level 2, if I will say level 1, this is the number 2, like level 2. This is the level 3. So what is the height of this tree? Height of this tree is 3. So when you are talking about, no, height of this tree is 3. This is the binary tree. Binary tree means root to children. Each and every node is having all the children. Like either it is having 2 children, left and right side, otherwise it don't have any kind of children. So that is, we can say that a kind of complete tree. And let's say this is the height. What is the height? 3. So if you want to calculate the number of node, you can calculate like this. 2 raised to 3 minus 1. So 8 minus 1. Now calculate. 1, 2, 3, 4, 5, 6 and 7. So total 7 nodes we got. So according to the height, you can calculate the number of nodes inside your tree. Got it? So this is how you can calculate how many numbers of nodes are there in your tree. We have so many types of trees available, like binary tree, binary search tree, balanced tree, an array tree, heap tree. Okay, but right now we are going to discuss about a simple tree, like it's a binary kind of tree. And yeah, AVL tree is also there. So these are the different types of tree that we have. Now, whenever you are creating any binary tree, so binary tree, it's something like, let's say, either the a particular node is having a children like this. Let's say I'll just make a very simple tree. 1, 2, 3. Let's say here we are having 2 children. I'm not talking about the complete tree, okay? This is just a simple tree which I have created. So this is having only one child, that is the left hand side, right hand side child. This is having left and right. This is having left and right, like this. So I can say that this is the root. These are the parents and these are the children's. Now how to traverse? How to traverse? Or simply we can say that traversal. So for the traversal, we have 3 types. One traversal is simply we can say that in order. In order is simply we can say that start from left hand side, go to the root and then go to the right hand side. So simply if I'll try to access the in order traversal, I will try to access like this. Left hand side 4, then 2, then go right hand side 5, then go to root, then go to left. But you can see there is nothing on the left of this. So we'll access 3. On the 3 also there is nothing on that left hand side. So we will try to access 6. So this is the in order traversal. Left, root, right. Okay, the one more traversal that we have, that is called pre-order traversal. Now pre-order means what? Starts from root. Starts from root, go to the left and then go to the right. So how you will start? Access the 1, then left. So on the left we will access 2. Okay, on that left, we will access 4. On the right, we will access 5. Again, go to the right hand side. So we will access 3 and then access 6. So this is something which we can say that pre-order. Pre-order means starts from root, then left, and then right. Another one that we have, it's called, let's say, post-order. So post order is something which will starts from left, then right, and at last root. So for that, how you will access? Starts from left. Left means 4. 4, then 5. Okay. Then you have to access 2. Then this is 3 and 6. So it will first access 6, then 3, then uh not 2, the 1. This is post order. Starting from the left, then access the right, and then access the root. So this is how we can do the order executions, like pre-order, post-order, and in order. So it depends on the requirement. If you want to access it in the ascending order, descending order, how you want to access the data. According to that, we can use the particular tree structure. So in that case, like sometimes, there is a binary search tree. And in the binary search tree, how the executions happen. Let's say, suppose I have a data. Okay. Like 10, 3, 7, 15, 25, and 18. Now, first element, make node, a root node. Second element, if it is smaller than 10, go on left side. Okay, if it is larger than then we'll go on right side. Now, what is 7? 7 is smaller than 10, but it is larger than 3. So it will come here. 50, it is larger than 10, it will come here. 25, larger than 10, larger than 25. So always right hand side, big elements. See, this is larger than 10, larger than 15, but smaller than 25, means 18 will come here. So this is how you can align, and this is called BST, binary search tree. So if you want to set the data in the ascending order or descending order, if you want to adjust, you can go for the binary search tree. Got it? Good to go, everyone? Any questions here? Now, how you have the elements, according to that, you can adjust. Let's say now you have received some element that is 2. So 2 you can put here. If you have an element, let's say 9. So 9 will go on the larger side of 7. If you have 13, 13 will go here. So something like that, you can try to align your data. So this is something which you can adjust in the binary search tree. Yeah, sure. Binary search tree is something like first element will become a root node, and other elements you can align like bigger one on the right hand side and the smaller one on the left hand side. So let's say if I have some data like 10, 3, let's say 9, and let's say 15, okay, 13, 7, like this I have, and let's say 25. So 10, I'm going to add it as an root node. 3 is smaller than 10, go on left hand side. 9 is smaller than 10 but larger than 3. So it will go on 3's right hand side. 15 is larger than 10, so it will go on 10's right side. 13 is larger than 10 but smaller than 15, so go on this side. 7 is smaller than 10, larger than 3, smaller than 9, so it will come here. 25, larger than 15, come here. Let's say I got some more elements, 5. 5 will larger than 10, smaller smaller than 10, larger than 3, smaller than 9, smaller than 7. So it will come here. If I got 2, 2 will come here. If I got 1, 1 will come here. Sorry. So this is simply, we can say that BST. And now here you try to access the in order. So you will get 1, 2, 3, 5, 7, 9, 10, 15. Sorry. Then 10, and after that 13, 15, 25. You always get the data in the ascending order. Got it? Yes. Okay, so how to code this? Okay, so let's start coding the same. So for this coding, again, I'm using the linked list data structure. So let's say create another package tree. Okay, we will try to do at least one or two traversal as well. So you can understand, I'm just trying to create one class. Let's say I want to create one node class and one class I'm going to create, that is the BT. Binary tree I'm creating, not binary search tree. Okay, simple one. Okay, let's say binary tree. Okay, so starting from the node class, you guys are already aware. So let's say data. Here we know we need two locations. One node will have two values, not only next. We have left hand side and right hand side. So node left, node right. Correct? Okay, constructor. Okay, so here what I will do, let's say we are going to insert some data. So I will say this dot data is equal to data. Okay, now left and right both I will align as a null. Left is equal to right is equal to null. Okay, so my node is ready. After that, binary tree. So for the binary tree, we will start from the root node. So use the node, create one root node, and we will create constructor. So under the binary tree, okay, how I will write? Let's say this dot root is equal to null. Okay. By default, obviously by default, the particular root node is null only, right? And later on, you can assign the data inside the same. Okay. Now for insertion, I'm going to align the values directly. Right now, I am showing you how to write the code for in-order traversal. Okay, so for that, what I'll do is, let's write a function. In order. Okay, I will take the node from where I want to traverse. Okay, my first question is, if my node is null, like I want to start from the root node. So I will check, is the root is null, there is nothing to traverse, right? So if it is null, then stop the process, return it from here itself. Okay, otherwise, recursion, calling the same function again and again. Okay, are you aware with the recursion? Okay, here I will apply the node dot left, means traverse the left hand side. Okay, access the main element, that is node dot data. Okay, space I will print, and traverse the same for the right hand side, node dot right. So this is something called recursion. Same function is going to trigger as per the execution. Like left, on the left, let's say left will become again the root node. It will check, okay, on this root node, do we have a left? Do we have a right? On the right node also become a root node. And then it will say, is there any element on the right hand side, left hand side, like left hand side and right hand side, like that. We are going to repeat the same process. So for that, this is the logic which we have written. Now, I'm also creating one more class here, that is, let's say, main. Okay. So in the main, I will just assign some values in my tree. Okay. Let's write a main method. Okay, and now under this main method, let's create an object. Okay, binary tree. Let's say I'm creating the binary tree object here, that is BT. Okay, and or simple, write a tree, new binary tree. Okay, this is done. Object is created. Now what I'll do is, let's say tree dot root. So on the root, I will create one object. Let's say new. I'm directly annihilating. Okay. Let's say I'm giving one. Okay. I'm saying tree dot root dot left. Okay. New node. Let's say 2. I'm just creating the data structure. Okay. Tree dot root dot right. 3. Tree dot root dot left nodes right. Okay. Let's say 4, or let's say left nodes left and left nodes right. Similarly, tree dot root dot right dot left, let's say 6. Tree dot root dot right, and that is 7. So this is something I have created, guys. Root is 1. On the one left, I have given 2. And here I have given 3. Here on the left and right. So here I have given 4 and 5. Here I have given 6 and 7. Are you clear with this? Now, if I will do the in order traversal, what should I get? 4, 2, 5, 1, 6. I think 6, then 3, then 7. No, 1 minute. 4, 2, 5, then we got 1. Then here it will start accessing this. Yeah, I think it should give me 6, then 3, and then 7. Right? Let's check that. Are we getting this kind of output? Yeah. So we have already written a logic for in order traversal. So if I will call this function, I should get this kind of output. Okay. So let's try to call tree dot in order. Okay, I want to start from which node? Let's say I want to start from tree dot root node, which we have already created here. So now let's run this and check what we are getting. 4251637. The one which I have created, similar kind of thing I am getting. I am getting in every time in a new line because here I have used a println. If I will not use the println, and here I will just print a message. Let's say in order traversal. Okay, and after completion, okay, but if I will write it inside, it will trigger every time because of the recursion, correct? So it should not write here. We can write it in a main. In order traversal started. And here I will write in order traversal completed. Okay, let's check this and see the output. See, Okay, are you clear with the in order flow? Similar to in order, let's write the logic for pre-order and post-order. Okay, so just like this, I'll copy, I'll paste the code, and I will just make a function named pre-order. So now what is the process for the pre-order? Okay, I will start pre-order left, okay, pre-order right, and then we will try to access this data last. Okay, so in this case, if I will try to run, okay, let's say for pre-order. Pre-order traversal started, pre-order traversal completed, and I will call the function named pre-order. And now if I will run, in the pre-order, what should be the output? Can you tell me what is the output for the pre-order? What is the process for pre-order? 1 minute. I think the logic which I have written, it's okay. Pre-order will access the root first, correct? Root, then left, and then right. This is the pre-order, correct? So according to our expectation, it will start from 1. Okay. What is the output? Let me see. Root, left, and right. Yeah, root first. So let's see the output. Are we getting as per the expectation? So let's run it for the pre-order. 1, 2, 4, 5, 3, 6, 7. Check. 1, 2, 4, 5, then 3, 6, and 7. Yes, pre-order is coming as expected. The same thing if you want to write for post-order. Post-order, the one which we have written earlier. Okay, so I'll just try to include that. Let's say post-order. Okay, so for the post-order, left first, right first, right after that, and the final is the root. So similar to this, let's try to call this again. Post order. Okay, let's call the function that is the post order. Okay, post order is completed. One more thing, I just copy pasted. So internally it is calling pre-order. So let's make it correct. Post order, post order, because recursion should be happen with the same function. Then only we can get the expected output. So now if I am running this, can you see? 452, then 673, and then it is giving you 1. Means root is coming at last. So this is the post order traversal. So this is how we can work with the tree. Are you able to understand, everyone? Yes. So Aditya, we have completed the tree concept. If you have any question, you can ask right now. After that, we will continue with the question. So we have completed the concept of tree. We are able to understand how the tree is getting executed. And we have completed the 3 types of traversal in the tree. That is in order, pre-order, and post-order. And we are able to see, as we have done with the diagram, that same traversal, we are able to do it with the code as well. Means what we are thinking, similar to that, we are able to get the output. So I think this is good to go, guys. So now I'm taking 1 minute pause here. Let me know if you have any question. All good, then we will go with the project implementation. No questions? Any questions? All good. Shall we proceed? Yes. Thanks for your update, guys. And now we want to implement the application, and our application is to-do list application. So these are the things that we have discussed here. Okay, how to implement the binary tree, how the operations are working. So we have implemented the basic things: in order, pre-order, post-order, implementation. Insertion, I have implemented with the help of direct execution, because right now we, as we are leading with this limited time span, we cannot complete the entire code structure. So say insertion and deletion I have done directly, and traversal we have implemented with all implementation. The class is blueprint. Then we started Java programs with making the class from the first line public class per without making the objects. I am creating the class as per my implementation, and I am creating the objects. This is the node class. This node class is used under the, this is something but the objects which I am using under the linked list class, binary tree class. And this binary tree is object I have created. Can you see that? And can you see these are the node objects created? So I am creating the node objects, assigning that to binary tree. And with the help of this tree, I am doing the data traversal. So these are the method executions which I have done. So we are using the blueprint here only, right? Okay. Maybe course content you will get after this completion. I will check with the team once what is the problem. Let me finish the application part and we will check all your queries related to this thing. Okay. Okay. So whatever the questions related to this certificates and all, please hold on, guys. Please focus on your learning. Okay. So that is something from my perspective I am suggesting to you. Please focus on your learning. If you know the things, certificate doesn't matter. Okay. So please focus here. Now, the very important thing which we want to implement is project, to-do list application. Now, it's up to you how you want to implement that using the array or how you want to implement using the linked list. Here again, we have already implemented two things with linked list. So I am just trying to jump on the array. How we can implement this to-do list application using the array. The features we are going to add it like add and remove functionality. We will create one task class, which is our individual task class, and another class which we will implement for our to-do application. Over there, we will write a functionality for add, remove, manage the task. Okay, undo functionality is optional. So right now we have not implemented that. Okay, we will get a time, we will implement. Otherwise, we will try to implement add, remove, and manage task functionality. Okay, so my project structure will be like, I'm going to create one class. That is the task class. I'm going to create one more class, that is the to-do list task class. Just like how node we have created, how binary tree we have created, and for the uses, we will create the main class. This is, we can say that uses class. So these are the three classes which we are going to create, where we will have a main method. This is the class where you will have the main method. Okay, and these are the blueprints which we will use. These are, we can say that, the blueprints. And these blueprints we will use here in the main class. So let's start implementing our project. Okay, so for implementing our project, I'm going to create one new project. Okay, so I'm just going to close all this. Let's create a new project. And my project name I will give, it's to do app. Okay, I'm going to create one package name. So again, my package name will be, let's say, org dot let's upgrade. Okay, it's giving the class name. So package I will give on the top. org dot let's upgrade dot to do, because this is my project name. Okay, and my class name is, let's say, task class. So class number 1, class number 2 is to do app. Always make sure the class name starts with the capital letter, and the main class is the main. So this is the project structure which I have created: task class, to do app class, and the main class. Now under the task class, we have to declare some variables. Okay, so I will create, let's say, one variable. Okay, that is the task name. So task name, I am giving it as a description. Okay, one more I am giving like Boolean value. Is the task is completed or not? So is completed. If it is false, means we will understand it's pending. If it is true, means we will understand our task is completed successfully. Now let's create a constructor. Okay, if you want to assign both the values, we can just try to create constructor using the fills. Is complete, we will assign the default value. So I'm just using the generator for generating the constructor, automatic generator. Super is not needed. Okay, description we will assign, and what we will do is completed. I will give the default value of this is completed is false, because by default the task is not completed. Okay, so this is something which we have added here. Now we can also generate the getter setter. If you want to generate the getter setter, you can just write like this. Source, let's say I want to generate the getter setters. So for generating the getter setters, let's say for description, and for this, generate. So getter method for description, let's say setter method is not required. You can remove it. Let's say we don't want the setter method. We can skip it. Is completed is getter method. And this set completed, if you want to complete is. Okay, so what we can do is, this is not needed. I will just make it, let's say, mark completed. Once you complete this, we will mark it. So when you mark completed, we will say it's true. Okay, so this is something simple logic which I have added. When you tick on this or something, like when you integrate this with the front end, right now we are just writing the backend data structure. So when you want to complete this, when you click on something or something, when you do, we can say that, okay, the task is completed successfully. Okay, if you want to print the task, you can generate the toString method. Let's say I want to generate using toString. So toString is an inbuilt one. You can also use it. Later on, you can make the changes to that. So see, this is the toString method. Okay, so can you see? Here, you can print the task. Okay, what is the task that we have? And let's say I'm just printing the task value. After that, if you want to print the completed, you can print the completed. And let's say you want to make the entire change here. You can try to print like this. Let me just show you. Okay, I'll just write a logic. Is completed. Okay, I will use the ternary operator. Okay, if it is completed, I will say the task is completed. Okay. If it is not completed, I will say it's pending like this. The task is pending. Okay, and after this, I will just attach. Here I will give a space. I will attach the name of the task, that is the description. So how it will looks like, if any time when you print the task object, it will say completed the name of the task, pending the name of the task. So this is something which I'm trying to print it using the toString method. Okay, whenever you want to generate anything, You just need to do the right click here, source, and select generate toString, generate getter setter, generate constructor. Select the fields and it will give you the auto generated code. Okay. So this is something, the first structure of my class which I have created. If you are okay with this code, we can proceed with the next task, that is the to-do app. Shall we proceed? Nothing I did. I just created description, 2 variables, 1 constructor, 2 getter method, 1 setter method, and 1 toString method for printing purpose. Simply, I can say that it's a POJO class, plain old Java object. Let's create next to-do app. Now to-do app, here we need a task array. So how we will write? Let's say private. I'm going to use the task array and the name I will give, it's a task. Okay, and if you want to give the number of task size, okay, so I will use like private int. Let's say these are the task count. How many tasks are there? Okay, let's set it using the constructor. Okay, so for that, we will set up a constructor. I will use one value, which is the size. We can take the size from the user. So how we will do? Let's say task is equal to new task with the size which is given by the user. Okay, and the number of task count we will give 0 because by default there are no tasks given. Okay, so this is simple initialization we have completed. Now let's write a logic for add task. So for adding a task, we are going to create a function. Let's say public void add a task. Okay, let's take a description from the user. Okay, and once you will get the description, we will update the task count. Also, what we will do is if the task count, if they are less than the task dot length, the task count are less than the task dot length, then let's create a new object of a task. Okay, so task, I will align that to the task count by incrementing the value. Okay, and then I will create a new object of a task by giving the description to it. So object created, assigned to that task array. Okay, and we will provide a simple message, task added successfully. Okay, so we will say task added and the name of the task, which is the description, which is given. Okay, in case, is there any error? Okay, we will provide the message, task list is full. Cannot add more tasks. Okay, clear with this? Adding logic, add the task. Similar to that, we want to implement the removal functionality. So let's write remove task. Now remove task, we are going to remove it based on the index. Okay, so let's say index. Okay, if you are not using the index, you have to do the linear search. You have to search the task and based on that task which you found, according to that, you can remove. So right now for the simple implementation, I am trying to search the task based on the index. Okay, so my first thing which I have to keep it, if the index is greater than or equal to 0, and if the index is less than the number of task count, then only you can remove it. If you are trying to remove some task named 50, the index 50, There are only 30 elements in your task array. How you will remove that? So it should be greater than or equal to 0 or less than with the task account. Then only you can remove. Okay. After that, we will provide a simple message. Let's say task removed. Okay. Let's say task removed. And the task, which task is removed, which is stored at the given index. We will print it first because after removal, you can't print it. Okay, so we are printing that like this is removing. Now, how you will remove that? So for that, I will take the help of for loop. Let's start from the index 0. Okay, or you can try to go from the reverse direction as well. Like, okay, start from the index. Okay, till its task count. Okay, and I will increase the value of I by 1. Now, why I did this, I'll tell you. Okay, task of that ith element, I want to take from the task from the I plus 1. Okay, and after completing this, I will say the task minus task count, which is null. So the element which you have removed, that I will make it null. Means that memory location I am clearing. Okay. And in case if it is not there, we will provide the error message. The index which you have given, it's invalid. Invalid index. Okay. Now, what is the purpose of writing this logic? Let me tell you. Removal is a very important thing. Listen. You have something like this. 1, 2, 3, 4, 5, 6. 0, 1, 2, 3, 4, 5. Now user said remove 3. So if you remove 3 in this continuous memory location, what happened? This place will become blank. How the sequential access will work? So we are doing what? Starting from this, shifting the values. This is shifting here, this we are shifting here, this we are shifting here. Okay, and this place which becomes blank, we are assigning it to null. Are you clear with this logic? We did the shift and the last value we made it null. Means this memory location we made blank. Are you clear with this logic? So that's why I did this. Okay. So once this is done, now one more logic. Let's say I want to print all. Okay. So for printing purpose, let's say I will write public void display task. And how you will start displaying the same? So I will start from if the task account, right? Task account. If the task account is equals to 0, means we will just print a simple message. There are no tasks available. No task available to show. Okay. In case you have that, go to the else part. And here we will try to print. Step number 1, print to do list. Next, start iterating. You can also write a for loop like this. Use index on array. So automatically it will give you the generated code. Starting from 0, go to the task.length it is giving. So you can go with the task.length also. Or else you can also use the task count. So any one will be fine. Incrementing the value. Okay. Starting from 0. less than task count. Why it is giving the problem here? Let me. Task count. Yeah. Okay. Maybe it's a typo error. Okay. After that, let's try to print the value. So for printing purpose, I will start like, let's say, what is the first task? So I will start from I plus 1. This is going to print the number dot, and then I am going to print the task. That is the task of that ith location. So it will print the task 1, task 2, task 3 like that. So this is the simple display task logic which I have written. Now let's try to create the object of this. Okay, there is some error in this existing code. Where it is? Okay, this file is not saved, because of that we are getting the error. When I saved this, it lost. Can you see that? It goes. Now here, main method में ऑब्जेक्ट बनाते हैं टू डू लिस्ट to do app we have created. Okay, to do app, let's say app, new to do app. Okay, let's say we want to give it with the size 5 tasks we want to add. Okay, I'll say app dot add task. Let's say check papers. Let's say conduct YouTube live, check assignments, operate session. Okay, front end training. Like this. I just assigned this. Now let's try to print it. Okay, app dot display. By default, all the tasks added. So by default, it should give pending. Let's run this. Can you see? Check paper is pending. This dot is coming after one with one space. If you don't want that space, you can remove that space and directly show the dot. It looks better. So if I will run this, you can take this input from the scanner as well. Like you can ask the user, what do you want to do? Users, you can ask the user, okay, you want to add a task, you can add a task. You want to print, you can print. This is something also you can take it from the user. Like user defined also you can make. So by default, it is showing all the task pending. Okay. And if you want to remove, we can also try app dot remove task. Let's say I want to remove it from the index number 3. And after removal, I will also print this again. So let's see that. So can you see it is showing me 4, means my removal logic is also working fine. Okay, are you able to understand this? Now in this case, if you want to change it from pending to complete state, so for that also you can write a logic. Like you can write one logic here. Let's say public. Let's say I will make it void complete task. I will say I want to give the complete task. So which index you want to complete? Okay. So let's say if same logic for the removal, which logic you have used, you can try to write like this. If it's found, we will update. Otherwise, we will say it's the task is invalid. Okay. So if we found this is invalid index, if it is found, we want to update. So here we will write a logic for making it complete. Okay. So task from the given index. Okay. Dot task. Okay. You can see we have this function available mark completed. So this is going to become true. Okay. And after that, let's print it. Let's say task marked as completed. Like it's a completed task. Okay. And what you can do is here, like you can also print the task which is marked as completed. Okay. So if I will run this, what I will do is before displaying this, I will also try to say app dot complete the task of the index number 2. So if I will run this, can you see index number 3, which is showing me task completed? Okay. But the problem we are facing is the task is completed, but we are not getting that value. Why it's so hectic? Because you have not started, like you have not started attending from the start. Maybe because of that reason, you are facing it as an hectic problem. We are trying to complete the task number 2. It's become completed. Then what is the issue? Okay, I got the issue. I think when we are trying to mark it as in completed, it's removing that description, maybe. Task, index. We can try to take that original value, like let's say it's a task object. Okay, I'll also include one setter method here because maybe it is overriding the data. Okay, so for this, I will also include the setter method here. Let's say set description, string description, and I can say that, let's say this dot description, which is the description. And here, when you are marking this as an completed, at that time, we can also say task index dot set description. From this object, we will get description. Task number 3, that is the check assignments, right? Check assignments, it's completed. I think there is no problem in this code, like from where it is creating the issue. We are trying to trigger this complete task. When it is completed, it should print this, right? Task marked as a completed, but we are not getting that. Okay, this complete task function is only creating the problem. Because it is not printing this. It should give us the response, that is the task marked as completed. Okay, let me try to trigger with the get description. No, 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 no. The thing is, this function is not actually, this complete task function is only creating some issue because it is going inside, but this is not printing something. So that is something which is creating the problem. Okay, let's say if I'll just comment out this code. Okay, let me try to run this. 5 tasks we have included. Removal is working. This is working. When we are trying to make the completion, only it is creating the problem. Okay, let's say app dot complete the task. I want to complete the task at the index 0. Means the first check papers. Yeah, now it is giving me the output. Can you see that? Task marked as completed, check papers. This is coming as expected. Okay, and now let me say display task. Okay, so when the task is getting completed automatically, obviously when the task is getting completed, we are not like expecting it should print the display like the description which is already completed. We are removing that description part, so that's why automatically the object is getting updated here. Okay, but no, no, if it's a typo error, Eclipse won't run. If it is a typo error, it won't run. It should give you the error. There is no error in the code. Right? But see, earlier we are not getting this thing. Like the task which you are marking, this is something which we are not getting with its description. So now we are able to get this. Let me show you this complete task. Check papers is the task. This we want to complete. So when you run this, can you see? I am getting task marked as completed. Check papers means check paper is completed task. Now we marked this. So we are able, like maybe earlier there is some issue, but now we are able to get the output. Okay. It's just because of we are not printing here. That is the get description. So now we are able to get it. So it's working as expected. Okay. So the entire project we have created. Now here you can also include the include process, like undo process also you can do. You can also try to implement something like in this main part, you can also try to add like the while loop. This loop is executed continuously and we will ask the user, okay, do you want to add a new task? Do you want to see the task? Do you want to remove a task? Do you want to complete the task? As per the user input, you can continue this process until the user says done. Okay. And you can break the loop. Otherwise, you can do the execution continuously. It's just like how the ATM is asking you the multiple questions. You can do it with the help of the switch case. स्विच केस यूज कर सकते हो, if else यूज कर सकते हो, स्कैनर से यूजर से इनपुट लेंगे एंड यू कैन कंप्लीट द एंटायर प्रोसेस. गुड टू गो. So we have completed the project with the 4 functionalities: task able to add, task able to remove, task able to print, and task we are able to complete. Complete functionality we have added more. As per the requirement, we are supposed to add only the 3 functionalities. So one more functionality we have implemented, that is complete task. Okay, good to go. Okay, I'm taking a pause and giving you 1 minute if you have any question. Otherwise, we will conclude the session for today. We have completed the data structure part with almost required concepts we have covered. Okay, Eclipse is something a editor. If you have any kind of typo error, your program won't run. Okay, so you can see the error here itself. If your program is not showing any error, means maybe some internal problem will be there. Otherwise, it should give you the output. Okay, so that is something which you need to take care. Okay, good to go. So this is the final session. Today we have completed this bootcamp. It's for 2 days only. Data structure and algorithms and the all the topics which we are supposed to cover, we have completed already, Aditya. This is the last day of our bootcamp. Yeah. Meanwhile, if you are writing any question, I am just I will push the code on the GitHub and I will share my GitHub link to the team. So when they are uploading the notes and everything over there, they will give you the GitHub link. Like team will give you. No need to share it from my side. Team will provide it to you. Fine. For the codes which I have shown to you, if you want to reference the code, we will use that. These are the advanced topic of data structure: hash table, hash key, heap. There are more available inside the same. So these are the advanced topic of data structure, which is not a part of this bootcamp. Yes. Whatever the topics which we have discussed related to that, if you have any question, let me know. Otherwise, we can conclude. All good? Great. Thank you. Thank you. Okay, please try to follow the code which I have explained. I think that will be giving you more clarity. I have added with the comments as well. Okay. So team will share you the links. From that you can use my Q code. Simple, very simple executions which I did over there. Yes, I think this much is enough. You can improve yourself by doing the more and more practice. Yeah. Yeah. So that's it. I think we are good to go, guys. You can refer the code once the team will share it, the links with you. So you can try to do the practice for the same. We'll meet again in our next bootcamp. Till then, do practice, keep learning, keep exploring, because this is the important thing in the IT field. Thank you. Thank you so much. Bye bye.